So imagine firing a massive piece of artillery. I mean, we are talking about a 100-pound piece of high explosive steel, leaving a barrel at supersonic speeds, just tearing through the sky toward a target.
Right. It's a massive physical event.
Exactly. It is, one of the most devastating forces on the battlefield. But if you look at the brutal reality of modern warfare, there is a terrifying catch for you, the person actually firing that gun. Because before that shell even lands on its target, which might be 30 or 40 kilometers away, the enemy already knows your exact GPS coordinate.
You do, and they know it instantly.
Right. Because their counter-battery radar has, tracked the trajectory of your shell in midair, their computers have calculated the parabolic arc backward to figure out exactly where it came from. And this is the crazy part. They have already fired their own shells back at you.
Yes.
So if you are standing next to that gun, how do you survive?
Well, the blunt answer is you don't. I mean, that is the stark, unforgiving reality of the modern battle space right now. Historically, the artillery was the one doing the hunting, right? They were firing from miles behind the front lines in relative safety.
Right, like way in the back.
Exactly. But now, the very second you pull that lanyard, you become the prey. The flash, the heat, the radar signature, it all basically paints a massive glowing target on your back.
Wow. So to survive that kind of, immediate lethal retaliation, the answer involves a technological leap that honestly sounds like science fiction to me. We are talking about 40-ton armored vehicles that can fire 155-millimeter shells with pinpoint accuracy, completely automated, all while driving down a highway at full speed.
Which is just wild to think about.
It really is. So, welcome to this deep dive. Today we have a massive stack of defense analyses, procurement reports, technical specifications, and military strategy documents. And we are going to use all of them to unpack a monumental shift happening right now in the Canadian Armed Forces. The mission for you, the listener, and for us today is to understand how things like drones and counter-battery radar are forcing a $5 to $6 billion complete redesign of artillery.
Yeah, and if we connect this to the bigger picture, when you look at the sheer scale of that investment, I mean, $5 to $6 billion, it becomes clear this is not just an equipment upgrade. The military is not simply, buying new trucks and bolting bigger guns to them.
Right, it's not just a shopping spree.
Far from it. What you're witnessing is a fundamental doctrinal shift. The military actually refers to this as Inflection Point 2025.
Inflection Point 2025.
Because for the last 2 decades, the focus of Western militaries was primarily on counterinsurgency operations, fighting insurgents. But now we are seeing a hard, urgent pivot back to high-intensity, peer-on-peer divisional combat. The battlefield has mutated, and the tools of the trade have to mutate with it, or, well, the consequences are fatal.
So I want to trace this mutation step by step. I mean, we need to look at why traditional towed artillery is effectively dead, and then explore the wild engineering of these new-wheeled, self-propelled howitzers. Plus, I really want to get into the intense physics of how a machine can possibly fire a massive gun while moving, and finally look at the digital nervous system tying all this together.
A lot of ground to cover.
It is. But to really grasp where we are going, we have to understand the specific capability gap we're trying to close first. So let's rewind a bit to the M777 towed howitzer. Why are we, just leaving it behind?
Well, to understand the M777, you have to look back to 2005. That was the year Canada retired its fleet of M109 self-propelled howitzers. And those were heavily armored, tracked vehicles.
Like tanks, basically.
Essentially, yes. But in the post-Cold War era, moving into the early 2000s, the threat of massive tank battles in Europe just seemed to have vanished. So the focus shifted entirely to the global war on terror. Retiring those old M109s left a huge capability gap for heavy indirect fire.
Oh, I see.
And the military filled that gap by purchasing 33 M7777 155mm towed howitzers.
And for a counterinsurgency environment like what we saw in Afghanistan, for example, the M777 actually made a lot of sense, right?
It did. It made perfect sense for that specific war.
Because it was incredibly lightweight for its size, right? It was made heavily of titanium. You could literally, hook it up to a CH-147 Chinook helicopter and sling load it over rugged mountain ranges to whatever forward operating base needed fighter support.
Exactly. The mobility profile was perfect for that specific era. In a counterinsurgency, you are generally setting up at a fixed fortified forward operating base.
Right.
You emplace the gun, you dig it in with heavy machinery, you build blast walls all around it, and you provide fire support for infantry patrols in the area. But the crucial factor there is that the adversary, like the Taliban for instance, did not have counter-battery radar networks.
Oh, right. They weren't tracking the shells in midair.
Exactly.
Yeah.
They did not have fleets of high-altitude surveillance drones either, so you could fire from a static position for hours, sometimes days, without any significant fear of the enemy returning heavy, coordinated artillery fire onto your position.
But the documents we're looking at today, they heavily reference the conflict in Ukraine, and the lessons being drawn from that theater completely shatter that old operational model, don't they?
They do, completely.
Because the sensor-to-shooter loop-like, the time it takes for an enemy to spot you and drop explosives on your head, has shrunk from hours down to mere minutes.
Yeah, it is an overlapping, constantly active web of surveillance now. You have those active counter-battery radars we mentioned, constantly emitting radio waves to detect incoming projectiles. You have high-altitude surveillance drones mapping the terrain in real time. And, you even have cheap, commercially available drones acting as forward observers.
Just everyday drones you can buy at a electronics store.
Right, but sometimes paired with low-cost loitering munitions that just circle an area waiting to spot a target. In that highly contested environment, the old adage applies with brutal finality. A stationary gun is a dead gun.
Wow. I was trying to picture what it must feel like to operate an M777 in that environment today. It feels like setting up a complex, heavy sniper nest in a room made entirely of glass. I mean, everyone can see you the moment you arrive. But wait, if they know they're being targeted, why can't the crew just hook the M777 up to a truck and drive away faster?
Well, the physical mechanics of a towed gun prevent rapid displacement. It's just not built for it. When an M777 fires, it generates an immense amount of recoil. To keep the gun from flipping over backward, it has these massive spade trails that are dug deep into the earth to anchor it.
Oh, like big metal spikes.
Exactly. Huge ones. So after you finish a fire mission, the crew has to physically dig those spades out of the dirt, fold the trails, lower the massive barrel, lock the traverse mechanisms, manually hook the immense weight of the gun onto the pintle hitch of a prime mover truck, and then finally slowly accelerate.
That sounds exhausting.
It is. And even for a highly trained elite artillery crew, that process takes vital minutes. When enemy counter-battery fire is calculated and in the air within 90 seconds of your first shot, taking 3 or 4 minutes to pack up your equipment is literally a death sentence.
Beyond the vulnerability to enemy fire, there's another detail in these sources that genuinely shocked me. It's about the physical toll on the humans operating these guns. The documents reference U.S. studies on Army Rangers who were deployed in Syria.
Yes, the TBI studies.
Right. They were conducting these high-rate-of-fire missions with the M7777 against ISIS targets, and the study showed that the crews were suffering from mild traumatic brain injuries just from firing their own weapon.
Yeah.
That's insane to me.
It is deeply concerning. But we have to consider the sheer physics of what happens when a 155mm shell is fired with a maximum propellant charge. I mean, it is a controlled explosion of terrifying magnitude.
Yeah.
When that happens, it creates something called blast overpressure.
Overpressure, okay.
Yeah, this isn't just a loud noise. It is a physical, supersonic wave of compressed air radiating outward from the muzzle and the breech of the gun.
And these soldiers are standing completely exposed just a few feet away from it, pulling the lanyard.
Repeatedly.
Huh.
For hours at a time. That invisible shockwave hits the human body, and more importantly, it passes right through the skull. The sudden spike in pressure causes the brain to basically microshift within the cerebrospinal fluid.
Oh, wow.
It causes microscopic tearing of neural tissue. The concussive force of repeated maximum charge firing from an open, unshielded platform is simply unsustainable for human health over the long term. The soldiers in those studies were reporting headaches, memory loss, nausea, and cognitive delays.
All classic symptoms of traumatic brain injury.
Exactly.
So the requirement for new artillery isn't just about moving faster to dodge enemy fire. It is fundamentally an occupational health necessity. Like, they absolutely require protective, climate-controlled, armored enclosures for the crew to shield them from the blast wave of their own equipment.
Yes. That requirement alone makes the towed gun entirely obsolete for high-intensity conflict. And the military is abandoning these legacy platforms so completely that it is even trickling down to domestic civilian operations, which is quite interesting.
Oh, yeah, the avalanche thing. The
Yeah.
sources highlight this fascinating anecdote. For 60 years, the military has had a contract with Parks Canada to use towed howitzers for avalanche control in Rogers Pass, British Columbia.
Right, they fire shells into the mountainsides to trigger controlled avalanches and keep the highway safe for drivers.
Exactly. But that contract will not be renewed when it expires in August 2027. They are phasing the towed platforms out of the inventory entirely, right down to domestic avalanche duty.
which leads directly to the core operational concept driving this massive procurement program. The entire $5 billion is centered on one doctrine: shoot and scoot. We talked about how you can't survive if you stay still. So the catalyst for Canada's Indirect Fires Modernization program, which they call the IFM, is to procure between 80 and 98 modern, highly automated self-propelled howitzers.
And what happens to the older stuff?
They're relegating the smaller, legacy 105mm towed guns strictly to reserve units for training purposes only.
Got it. The mandate is clear then. You must be able to roll into a firing position, unleash a high volume of heavy shells, and displace from that coordinate immediately before the enemy can physically react.
That is the absolute baseline for survival now.
Okay, so if towing a gun is a death sentence, the logical, historical next step would be to just put the gun on a tank chassis, right? Go back to heavily armored, tracked vehicles like the M109s we retired in 2005. But when I look at the requirements the Canadian Army laid out in their Request for Information, the RFI, they did something very specific that effectively banned heavy tank tracks from the competition entirely.
Yes, they did. They instituted very rigid, mathematically uncompromising mobility filters. The RFI demands that whatever vehicle carries this new artillery system must have a minimum road speed of 80 kilometers per hour.
80 kilometers per hour.
And it must have an operational range of 450 kilometers on a single tank of fuel.
And that completely upends the traditional approach, because the sources specifically point to South Korea's Hanwha K9 Thunder. And Hanwha was pushing this system hard, right? They were marketing it as the Arctic gun of choice, pointing to its heavy armor and its tracks as ideal for traversing deep snow.
They were, yes. But its maximum road speed is only 67 kilometers per hour, and its range is only 360 kilometers.
So it just fails the test immediately.
It does. The K9 Thunder is an incredibly capable machine, highly regarded globally, but it physically cannot meet Canada's baseline strategic mobility requirements. And if we look at the underlying reasons for those requirements, it comes down to the brutal geographic reality of Canada. A tracked vehicle, which is essentially a tank, operates very differently from a wheeled vehicle.
How so? I mean, I think most people, myself included, just assume tracks are always better for off-road military applications. Like, tanks have tracks for a reason.
Well, off-road, for short tactical movements in deep mud or snow, tracks are excellent because they distribute the weight of the vehicle over a much larger surface area, which lowers the ground pressure. But the strategic requirement here is the ability to move these artillery pieces across Canada's massive continental expanse.
Right, Canada's huge.
Exactly. Cracked vehicles are incredibly destructive to paved road surfaces over long distances. The steel links and the sheer heavy weight will literally tear apart municipal highways. Furthermore, they are slow when transiting strategically, meaning if you need to move a fleet of them from a base in Quebec to a port in British Columbia, you can't just drive them. You have to load them onto specialized heavy equipment transporter trucks or load them onto rail cars.
So you literally can't just drive them there.
No, the logistics of driving them there would be catastrophic, primarily because of fuel consumption. A heavy mechanized track division can consume upwards of 20,000 liters of diesel a day.
20,000 liters a day. That is an unbelievable amount of fuel.
Now imagine trying to sustain that fuel line. Every single drop of that 20,000 liters has to be transported in soft-skinned, highly vulnerable fuel trucks, driving along predictable supply routes. In a high-intensity conflict, those fuel convoys become prime targets for enemy drones and special forces.
And if the fuel stops?
If the fuel stops, the artillery stops. It becomes a stationary pillbox. And if you try to deploy those tracked systems to the Canadian Arctic, sustaining that volume of diesel along isolated ice roads or via airlift is nearly impossible.
Okay, so wheeled vehicles offer a massive logistical advantage here. They can self-deploy. You can just start the engine and drive them down the Trans-Canada Highway at 80 kilometers an hour without needing a massive fleet of flatbed trucks or consuming half the nation's diesel reserves.
Exactly. They offer strategic independence. Now, to be clear, the military is not abandoning tracks entirely in the north. The sources note that separate, highly specialized tracked vehicles, like the BAE Beowulf or the Voyager D-12, are being procured.
Oh, right.
But those are purely for Arctic logistics, hauling cargo and troops across deep snow, not for carrying 40-ton artillery turrets. For the heavy guns, wheels are the only path forward.
Which brings us to the main contender for this $5 billion contract, the Grizzly LAV SPH. This vehicle was unveiled at the CanSec 2026 Defense Exhibition by General Dynamics Land Systems Canada and Germany's KNDS. Now, I'm looking at a picture of this thing in the sources, and it looks completely absurd.
It is quite a sight.
It looks like a stretched limousine version of a tank. It has 10 wheels, a 10 by 10 configuration based on the MOAG Piranha the Filth chassis. Why on earth does a vehicle need 10 wheels?
It comes down to managing immense concentrated weight. To understand the 10 by 10 design, we have to isolate the weapon system itself first. The core of the Grizzly is the uncrewed KNDS artillery gun module, or the AGM. Just the turret, the metal box containing the gun, the autoloader, and the mechanics weighs 12.5 metric tons, completely empty.
12.5 tons? That's the weight of a city bus, just for the turret alone.
Yes. Then you must add the combat load. That means 30 heavy 155 millimeter high explosive rounds. It means 144 modular propellant charges. It means the heavy ballistic armor required to protect the crew sitting in the chassis below from both enemy fire and that blast overpressure we discussed earlier. When fully loaded, the entire vehicle tips the scales at 39 metric tons.
Wow. So if you tried to put 39 tons on a standard 8-wheeled armored vehicle...
The axle load limits would be pushed way beyond their engineering tolerances. The vehicle would sink instantly into soft soil, mud, or snow because the ground pressure per square inch would just be too high. The 10 by 10 design, adding that fifth axle, spreads the 39 tons out over a much larger footprint, drastically lowering the ground pressure.
That makes sense.
But there is a secondary, equally vital mechanical reason for the lengthened chassis.
The recoil.
Yes. When 155 millimeter gun fires, the kinetic energy pushing backward is staggering. In older wheel systems, the crew would actually have to lower heavy hydraulic stabilizing legs down into the dirt to absorb that recoil and stop the truck from flipping over.
Right, which takes time.
Exactly. The 10 wheels and the stretched chassis of the Grizzly provide enough mass and longitudinal stability to absorb that recoil entirely through the vehicle's internal suspension system. No hydraulic legs are required.
Okay, wait, hold on. I need to push back on this a bit. The sources mention that the UK and Germany are buying a very similar system from KNDS called the RCH-155, right?
Yes, they are.
And it uses the exact same artillery turret, but they are mounting it on a smaller 8x8 boxer chassis. If 8 wheels work just fine for Germany, why is Canada insisting on a custom 10-wheel behemoth? Does it a longer vehicle just make it harder to maneuver in tight spaces like a forest or a narrow urban street?
There is absolutely a trade-off in turning radius and maneuverability in tight confines. The decision to go with the 10 by 10 Grizzly over an off-the-shelf 8 by 8 Boxer comes down to two highly specific Canadian requirements: industrial commonality and crew configuration.
Okay, break that down for me.
Well, General Dynamics Land Systems Canada, which is based in London, Ontario, already produces the LAV 6.0 and the Armored Combat Support Vehicle for the Canadian Army. The Grizzly, despite being stretched out, maintains high parts commonality with Canada's existing fleet of over 11,000 LAVs.
So it's a mechanic's dream.
From a logistical standpoint, it simplifies everything. If a suspension arm breaks on a Grizzly out in the field, a mechanic can likely use a spare part from a standard infantry LAV to fix it. The training pipelines for mechanics don't need to be entirely rewritten for a foreign chassis. The supply chains for oil filters, brake pads, and engine components already exist natively.
That is a huge advantage. What about the crew configuration? You mentioned that as the second point.
Right. The human capability aspect. The German RCH-155 is highly automated and designed for a crew of 2. But the Canadian Grizzly features a crew of 3, a driver, a commander, and a systems operator, all sitting inside the heavily armored front hull.
Why do we need an extra person if the turret is a robot? Doesn't that just put another life at risk?
Because operating independently in a high-intensity conflict requires an immense amount of situational awareness. While 2 crew members might be sufficient to just drive and approve fire missions, that third crew member is critical for managing complex digital communications, monitoring local drone feeds, and handling the vehicle's local defense systems.
So they are like the ultimate multitasker.
Exactly. If an enemy infantry patrol ambushes the vehicle, you need someone manning the defensive machine guns or the remote weapon station, while the driver focuses entirely on evasion. You can't ask the driver to do both.
Okay, so we have this massive 40-ton, 10-wheeled machine. It's built in Canada. It shares parts with our existing fleets, and it can drive thousands of kilometers across the country without tearing up the highways.
Correct.
But its most impressive feature, the thing that makes it a true generational leap, isn't how it drives. It's what it can do while it is driving. I want to talk about the physics of survival here because the technology borders on magic.
It really does. The request for information demands a capability that, until extremely recently, was considered physically impossible in artillery doctrine.
Firing on the move.
Yes, the ability to fire indirect artillery targets while the vehicle's actively moving. Currently, only the KNDS artillery gun module turret can execute this.
Let's break down the gun first, because I was reading these technical specs, and I have to admit I got a little lost in the weeds. The documents say it is a 155 millimeter L52 barrel, and that it is JBMO compatible. Can you translate what an L52 barrel actually means for those of us who aren't artillery officers?
Of course. The L stands for caliber length, and the 52 is the ratio. It means the length of the barrel is 52 times the diameter of the bore. So a 155 millimeter bore multiplied by 52 gives you a barrel roughly 8 meters long.
8 meters. Okay, why does the length matter so much? Why not just use a shorter, lighter barrel so the truck isn't so front-heavy?
Because of internal ballistics. When the powder charge ignites in the breech, it creates rapidly expanding high-pressure gas that pushes the shell down the tube. The longer the barrel, the more time that expanding gas has to act upon the shell, accelerating it.
Oh, so it just gives it a longer runway to speed up?
Precisely. A longer barrel directly equates to higher muzzle velocity, which equates to longer range. An L52 barrel allows the system to hit targets 40 kilometers away using standard base bleed ammunition.
Okay, there's another term I need you to unpack: base bleed ammunition. I always assumed artillery shells were just giant bullets, but base bleed sounds like a rocket. Is it a rocket-propelled shell?
Not quite. It's a very clever solution to an aerodynamic problem. When a large artillery shell travels at supersonic speeds, the blunt rear end of the shell creates a massive low-pressure pocket, essentially a vacuum, right behind it as it flies.
Okay, I'm visualizing that.
That vacuum creates base drag, which actively pulls the shell backward, slowing it down and significantly reducing its range. Base bleed ammunition has a small pyrotechnic charge at the very base of the shell. As the shell flies, this charge burns, not to provide forward thrust like a rocket, but simply to expel hot gas into that vacuum behind it.
No way, so it just fills the empty space.
Yes. By filling the low-pressure void with gas, it drastically reduces the aerodynamic drag, extending the range by up to 30%.
That is brilliant, just bleeding gas to smooth out the airflow. And the sources mention that if they use advanced volcano rounds, the range extends up to 70 kilometers. 70 kilometers is massive.
It is. And volcano rounds are a step further in engineering. They are subcaliber, meaning the actual projectile is smaller and more aerodynamic than the 155 millimeter barrel. It's enclosed in a sabota casing that falls away immediately after firing.
Oh, like a tank shell.
Exactly. Plus, they have fins for stabilization and programmable guidance systems on board, allowing them to glide and steer toward a GPS or laser-designated coordinate with terrifying precision at that 70-kilometer range.
Okay, so we have a massive long-range gun. But here's the part that melts my brain. How does it fire accurately while moving? If I'm driving down a bumpy gravel road at 30 kilometers an hour, I can barely drink a cup of coffee without spilling it on myself. How does a machine calculate a parabolic arc to hit a target 40 kilometers away while the vehicle is pitching and rolling over ditches?
It utilizes a technology called active coincidence control.
Active coincidence control. Okay, how does that work?
Well, the gun barrel is not rigidly locked to the chassis of the truck. It is stabilized on independent axes, much like a gimbal on a handheld camera or a drone, but obviously scaled up for a 12-ton weapon. The onboard computer acts as a PID controller, processing thousands of data points every single second.
Data from where? Like, what is it measuring?
From gyroscopes measuring the tilt of the Earth, from suspension sensors measuring the exact compression of each of the 10 wheels, and from GPS measuring the vehicle's speed and heading. So if the front left wheel hits a rut and dips down, the computer instantly calculates how that dip affects the angle of the barrel. It then commands high-speed servo motors to twitch the barrel in the exact opposite direction to maintain a perfect, uninterrupted lock on the spatial firing coordinate in the sky.
It's like a chicken's head. Have you seen those videos? You can move the chicken's body all around, but the head stays perfectly locked in space.
That is exactly the principle, yes. But applied to a weapon that must maintain an angle within fractions of a degree to avoid missing a target by hundreds of meters.
I used this analogy when I was reading the notes because I was trying to wrap my head around it. Think of a biathlete in the Winter Olympics. Normally, the doctrine is you ski incredibly hard, you stop, you spend precious seconds calming your breathing and lowering your heart rate, you carefully aim your rifle, and you shoot.
Traditional artillery.
Exactly. But this active coincidence control technology is like a biathlete shooting a perfect bullseye while actively skiing downhill at full speed. It just doesn't compute in traditional artillery thinking.
It completely shatters traditional doctrine. And when we look at the survival math laid out in the analyses, the advantage becomes undeniable. Let's compare a fire mission between a traditional system and the Grizzly. With an older self-propelled gun, the vehicle drives to a coordinate, stops, deploys stabilizing legs, fires its shells, and then prepares to move.
Which, as we discussed earlier, takes at least 30 to 60 seconds just to retract the legs, secure the gun, and slowly accelerate a massive heavy vehicle from a dead stop.
And during those 30 to 60 seconds, enemy counter-battery radar has already detected your first shell, calculated your location, and enemy artillery is currently falling through the sky toward your immobile position.
So you're literally a sitting duck while you try to put the vehicle in gear.
Precisely. Now, analyze a fire mission with the Grizzly. The vehicle is already moving at 30 kilometers per hour. A fire mission comes in digitally. The turret rotates, the active coincidence control stabilizes the barrel, and the gun fires while the truck continues driving at 30 kilometers per hour without ever touching the brakes.
The enemy radar still detects the shell, right? They still calculate where it came from.
Yes, they do. Let's assume a highly competent adversary. It takes them 90 seconds to track your outgoing shell, pass the coordinates to their own guns, and have their retaliatory strike impact the Earth. In those 90 seconds, the Grizzly, maintaining its steady speed of 30 kilometers per hour, has traveled 750 meters away from the firing coordinate.
3/4 of a kilometer away.
By the time the enemy shells explode on the coordinate where the Grizzly was, the Grizzly is long gone. It guarantees platform survival because it breaks the fundamental assumption of counter-battery fire, that the origin point of the attack is a static, strikeable target.
And it isn't just firing one shell and running away either. The sheer volume of fire this automated turret can output is terrifying. The documents state this system has a sustained rate of fire of 8 to 9 rounds per minute. And there is no human physically lifting 100-pound shells in a cramped, smoky cabin anymore.
The automation is total. The shells are extracted from the magazine mechanically. The modular propellant charges are loaded mechanically based on the required range. Even the fuses, the small electronic nose cones that tell the shell whether to explode on impact, delay for a bunker, or airburst above a trench, are programmed inductively by the computer while the shell is being rammed into the breech.
Wait, inductive programming, like wireless charging for a phone?
Very similar, yes. As the shell slides past a sensor in the autoloader, the computer wirelessly transmits the detonation instructions directly into the fuse's microchip in milliseconds. The crew simply inputs the parameters on a touchscreen.
I assume that level of automation is about speed, but is there a deeper tactical reason for removing the physical labor?
If we look at the grim reality of attrition warfare, removing physical human labor is a massive force multiplier. A crew of extremely fit human loaders gets fatigued. After lifting 100-pound shells in 40-degree heat for an hour, their rate of fire will inevitably drop. A robotic rammer does not get tired. It does not get distracted. It guarantees that a high, sustained volume of precision fire can be maintained indefinitely. Furthermore, this extreme automation enables MRSI capabilities.
MRSI? That's multiple round simultaneous impact, right? How does that work? How can multiple rounds impact simultaneously if there's only one barrel?
It is a ballet of physics and timing. The computer calculates different parabolic arcs for a single target. The gun fires the first shell at a very high steam trajectory. The barrel instantly lowers a few degrees, less propellant is loaded, and a second shell is fired on a slightly flatter, faster trajectory. The barrel lowers again, and a third shell is fired on a direct, shallow trajectory.
So the first shell spends a long time in the air, while the leader shells take a faster shortcut.
Exactly. The timing is calculated perfectly, so that all 3, 4, or 5 shells, despite being fired consecutively over several seconds, converge and detonate on the target at the exact same millisecond. To an enemy on the receiving end, it feels like an entire battery of artillery just hit them, when in reality, it was a single Grizzly driving past.
That is just wow.
The RFI also specifically notes a requirement for direct fire modes.
Direct fire, like a tank aiming straight at a target in its line of sight.
Yes. While artillery is designed for indirect fire over the horizon, the Canadian requirements note this direct fire capability is highly desirable for anti-ship operations along Canada's massive undefended coastlines. A Grizzly could park on a cliff in the Arctic and engage hostile vessels directly.
Okay, so an incredible gun, But no matter how fast it fires, how well it drives, or how cool MRSI is, it is completely useless if it doesn't know where to aim. We talked about how the battlefield is flooded with drones and sensors. The hardware needs a nervous system to process all that data.
And that brings us to the Joint Fires Modernization Project, the JFM. This is a massive parallel procurement, ranging between $250 million and $499 million. It is entirely focused on creating a digital C4I, framework command, control, communications, computers, and intelligence.
So JFM is the digital brain. Its sole purpose is to digitize that sensor-to-shooter loop we keep talking about.
Yes, the goal is to eliminate human friction in the transmission of targeting data. Imagine a scenario. A small infantry drone operator spots a camouflaged enemy command post. Historically, that soldier would have to read the GPS coordinates off their screen, key a radio, verbally read a string of numbers to a battery command post, where another human would write them down, manually calculate the wind and weather data, and then yell those instructions to a gun crew.
Every step in that chain introduces the possibility of human error. A transposed number means the shell misses by a mile.
And it takes time. The JFM project creates a digital handshake. The drone operator tags the target on a digital map on a tablet. Those exact coordinates are instantly broadcast over secure, jam-resistant tactical networks. They bypass the verbal relays entirely and appear directly on the fire control panel inside the Grizzly. The computer cross-references those coordinates with its own GPS location, pulls in atmospheric data from meteorological sensors, calculates the exact barrel elevation and powder charge required, and presents a ready-to-fire prompt to the crew.
The human operator just has to review it and authorize the strike.
Right. The human remains in the loop for ethical and tactical oversight, but the complex mathematics and the data transmission are handled by the network in seconds. But it's important to note that the IFM program isn't just about the massive 155mm Grizzlies. You don't use a sledgehammer to swat a fly.
Right.
The sources make it very clear this is a layered portfolio approach. They are building an entire interconnected ecosystem of indirect fire.
Because an Army division needs tools of different sizes. And alongside the heavy artillery, they are integrating a massive new mortar fleet.
Up to 99 heavy 120mm mortar systems will be integrated into wheeled LEV 6.0 armored combat support vehicles. One of the leading candidates specifically mentioned is the Patriot Nemo.
What makes the Patriot Nemo different from the old mortars where soldiers just dropped a bomb down a metal tube?
The Nemo is a fully enclosed remote-controlled turret mounted on the roof of the armored vehicle. The soldiers stay safely inside the hull. And critically, just like the Grizzly, the Nemo is capable of firing its 120mm mortar rounds while the vehicle is moving.
So the infantry units get their own mini Grizzlies. They have immediate heavy fire support riding alongside them, and they don't have to wait to call in the division-level heavy artillery for every engagement.
It provides organic, immediate suppression. And for the light infantry, the troops who need to be highly mobile, operating in dense forests or being airdropped into rugged terrain, the portfolio includes the procurement of 85 to 133 modern 81mm mortars.
Wait, hold on. We just spent 20 minutes talking about how towed static weapons are a death sentence. Why on earth are we buying towed 81mm mortars? Aren't we putting those light infantry soldiers in the exact same danger from counter-battery radar?
It is a valid concern, but the tactical reality of light infantry requires a different calculus. First, the 81mm motor is significantly smaller. Its radar signature is much harder to detect than a massive 155mm shell, and its range is much shorter, often used in close proximity where heavy counter-battery fire would actually risk hitting the enemy's own troops.
Oh, danger close. Got it.
Exactly. Secondly, they are addressing the mobility issue. The old 81mm mortars were hand-portable. Soldiers literally had to carry the heavy steel baseplates and tubes on their backs, meaning their displacement speed was a slow walk. The new plan mounts these modern mortars directly onto light tactical vehicles, essentially specialized, rugged off-road buggies. They can fire and drive away rapidly, providing the necessary shoot-and-scoot capability tailored specifically for light off-road forces.
And the Department of National Defense isn't stopping with traditional explosives either. The documents indicate they are looking at integrating loitering munitions into this digital network.
Yes, often referred to in the media as kamikaze drones. Loitering munitions blur the line between a sensor and a shooter. You can launch one, and it will orbit a designated area for hours, sending high-definition video feeds back to the commanders. It acts as an eye in the sky. But the moment a high-value target emerges, say and enemy air defense radar powers on, the operator doesn't need to call in artillery. They simply command the drone to dive, and it becomes a precision-guided missile detonating its onboard warhead on the target.
Okay, looking at this whole picture, highly automated turrets, digital targeting networks, calculating ballistics instantly, drones picking targets and diving on them, I have to ask the question that naturally arises. Are we replacing soldiers with robots? Is the human element being phased out of the artillery corps?
It is a very logical concern when you look at the sheer volume of automation. But the reality laid out in the force structure documents is actually the exact opposite. This digital shift does not eliminate jobs. It requires more highly specialized personnel. The Modernization project anticipates needing an additional 1,500 troops to operate, maintain, and sustain these highly complex systems.
1,500 more troops. So the job is fundamentally changing, not disappearing.
The skill set shifts dramatically. It moves away from the grueling physical labor of manually loading heavy shells in the mud, digging spade trails, and calculating math on paper charts. The cognitive load on the soldiers increases exponentially. They are transitioning into network managers, drone operators, electronic warfare specialists, and technicians who can troubleshoot complex robotic servo motors in the field. They have to execute rapid, complex tactical maneuvers in a digital environment where the sheer volume of information can be overwhelming.
So getting all this cutting-edge technology, the Grizzlies, the Nemo turrets, the light tactical vehicles, the digital JFM networks, into the hands of those 1,500 soldiers requires navigating the notoriously complex world of defense procurement. And it's not like buying a fleet of delivery vans off a dealership lot, is it? We need to look at the strategic industrial reality and the geopolitical pressures that are forcing a massive rush on this timeline.
The timeline is being intensely compressed by three factors: funding, bureaucratic redesign, and an immediate operational threat.
Yeah.
On the financial side, the 2025 federal budget allocated a staggering $81.8 billion over 5 years to the military.
But having the money is only half the battle. The Canadian defense procurement system is historically, well, famously slow. We take decades to buy helicopters or ships. How do you stop this massive influx of CAF from getting bogged down in years of red tape and committee reviews?
The government recognized that structural bottleneck. To bypass the traditional pipeline, they created a new entity, the Defense Investment Agency, or the DIA. Their specific mandate is to take over and fast-track any procurement project valued at over $100 million. They are designed to cut through the interdepartmental friction and get contracts signed rapidly.
And a major requirement of those contracts is domestic production. Canada's overarching defense policy, which is titled Our North, Strong and Free, strictly mandates sovereign industrial capacity. The logic is sound. In a major global conflict, global supply chains will fracture. We cannot rely on overseas factories to supply our critical munitions if those shipping lanes are contested.
This is where the Munitions Supply Program, the MSP, is activated. Canadian industry is being heavily leveraged. For example, IMT Defense, located in Ontario, will be responsible for forging the heavy steel bodies for the new M795 and M1128 base bleed shells. Those empty steel shells are then shipped to General Dynamics Ordnance and Tactical Systems Canada in Quebec, where they are meticulously filled with high explosives.
And building the Grizzly itself locally in London, Ontario by GDLS Canada fulfills the massive Build in Canada industrial offset requirements. It keeps the engineering knowledge, the jobs, and the supply chains securely within our borders.
That domestic industrial base is vital for long-term sustainment, yes. But the frantic urgency of this procurement is being driven by the immediate physical threat on NATO's eastern flank, specifically Canada's commitments under Operation Reassurance.
Canada is the framework nation leading the NATO multinational brigade in Latvia, and this deployment has scaled up massively in recent years, hasn't it?
It has transitioned from a small tripwire force to a full combat-capable brigade. The footprint is now roughly 3,500 troops, with 2,200 of those being Canadians. They are positioned forward, right on the border, to deter and, if necessary, counter potential Russian aggression.
And this is where the terrain becomes a massive problem for the old towed artillery. I was looking at topographical maps of Latvia when preparing for this deep dive.
The Baltic terrain is highly specific. It is famously flat, incredibly open in areas, and heavily characterized by swamps and soft, boggy ground. When military planners analyzed the tactical situation, they realized they had a severe problem. Deploying those old, static, towed M777s in that specific environment was identified as a major vulnerability.
Because there's nowhere to hide. You can't tuck a gun behind a mountain if there are no mountains, and if the ground is swampy, digging those heavy spade trails in to stabilize the gun becomes a nightmare.
Exactly. The counter-battery fire from a mechanized adversary would be devastating in that open terrain. The commanders recognized that waiting years for the Grizzly to finish development and production was an unacceptable risk for the soldiers deployed right now.
So they needed stopgaps. The sources detail a flurry of urgent operational requirements, or URRs, being executed to patch these holes immediately.
While waiting for the heavy armor, they used URRs to purchase $32.2 million worth of PAXM anti-tank missiles, giving the infantry immediate heavy lethality. They rapidly deployed medium-range radar systems to Latvia to at least detect incoming threats faster. But the most significant stopgap involves artillery. To provide immediate mobile fire cover for the brigade in Latvia, Canada has had to rely on a small number of Archer self-propelled howitzers procured from Sweden.
It's like realizing your home insurance policy is wildly out of date, just as a Category 5 hurricane is forming off the coast and you are scrambling to board up the windows with whatever local materials you can find while you wait for a contractor to rebuild the roof.
It is a frantic race to reinforce a vulnerable posture. But this raises an important question, one that defense analysts and logisticians are watching with deep anxiety. Can domestic supply chains actually handle the relentless, ravenous demand of modern attrition warfare?
What do you mean by that? If we are forging shells in Ontario and filling them in Quebec, shouldn't we be self-sufficient?
It is a question of scale. Look at the data coming out of the United States. To feed the intensity of the conflict in Ukraine, the U.S. defense sector is currently trying to push their industrial output to 100,000 artillery shells a month.
100,000 shells a month. That is an astronomical volume of raw steel and chemical explosives.
It requires a colossal, unbroken flow of raw materials.
Yeah.
Canada must not just buy these new advanced Grizzly guns. Purchasing the hardware is the easy part. The government must guarantee a multi-year, contractually ironclad flow of steel, nitrocellulose for the powder, and microchips for the fuses. There are massive global bottlenecks for raw explosives right now. If Canada does not lock down that continuous supply chain and expand its domestic production capacity to match the burn rate of a high-intensity conflict, these incredible 40-ton, $5 billion machines will run out of ammunition in a matter of weeks. And a highly automated, active, coincidence-controlled gun without ammunition is just a very heavy, very expensive armored truck.
It's a sobering reality check on the logistics of modern war. Let's look at the incredible journey we have mapped out today. We started with the vulnerable, static-toed guns of the past. The M772s that serve perfectly in counterinsurgency but are simply sitting ducks in a modern peer-on-peer fight. We watched that brutal realization lead to the massive 10-wheeled Grizzly, an absolute marvel of engineering that solves the physics problem of firing 155mm shells accurately while driving at full speed, all while keeping its crew safe inside an armored hull. We explored how a digital brain, the Joint Fire's Modernization project, will link sensors and shooters in seconds, supported by a layered fleet of wheeled mortars and loitering munitions. And finally, we've seen how this is all being driven by the urgent geographical realities of securing NATO's eastern flank in Latvia, backed by a domestic supply chain that is rushing to keep the ammunition flowing.
The engineering and the logistics are fascinating, but as we wrap up, I want to leave you with a final concept to mull over. We've spent an hour discussing the physical mechanics and the tactical mathematics of survival. But consider the profound psychological shift this technology imposes on an adversary.
The psychological shift.
For centuries of human warfare, artillery was a fixed point on a map. It was a geographic reality. A battery set up on a hill, and it bombarded you. It was a place you could find, a coordinate you could target, and a position you could eventually destroy. But how does an enemy commander plan a defense or organize an assault against a mechanized force when the artillery bombarding them is effectively a ghost?
A ghost, wow. Because you can't hunt something that doesn't exist in one place.
Think about the terror of that reality for a soldier on the other side. It is a weapon system that moves constantly. It calculates ballistics perfectly on the fly, unleashes a devastating multiple-round simultaneous impact strike, and leaves absolutely no physical trace of its firing position by the time the counterstrike arrives. The enemy radars see the incoming fire. They plot the origin coordinate perfectly, they expend precious ammunition firing back at that coordinate, and their shells hit empty dirt every single time.
We talked earlier about the old M777 being like a sniper in a glass house. Everyone can see you, and if you don't move, you die. But the Grizzly flips that dynamic completely. It takes the glass house and replaces it with an invisible predator. The enemy knows they are being hunted, they can feel the impacts, but they're swinging wildly in the dark at a target that is already miles down the road.
It completely rewrites the psychological terror of the battlefield. It forces the enemy to constantly second-guess their intelligence, ruins their morale, and spreads their resources incredibly thin as they desperately try to hunt an adversary that simply isn't there anymore.
It is a terrifying, fascinating leap in technology driven by an unforgiving new reality. Thank you so much for taking this deep dive with us today. Keep your curiosity sharp, and we'll see you next time.